Mana Labs. In today's session, we will look at chapter 2, that is polynomials. So algebraic expression called polynomial, let's look at the terminology. Okay, then in this chapter we will cover polynomial in one variable. We'll also look at zeros of a polynomial. Remainder theorem. Factorization of polynomials. Factorization. And then we have algebraic identities. So first, let us look at polynomials in one variable. So let us consider some examples here. Say we have x squared plus 2x. Okay, so here x is called the variable, and there's a single variable in this case. Okay, so these are polynomials in one variable. Few more examples that we can look at. Say 2x, or say you have minus x squared plus 4x plus 7. So all these are examples for polynomials in a single variable. So another example I can consider, say 3y squared plus 5y. So this is also a polynomial in one variable. In this case, the variable is y. Let's consider t squared plus 4. So here the variable is t. Okay. Now these are called terms. Let me consider this example. So x squared plus 2x. X squared is one term and 2x is the other term. So these are called terms of the polynomial. And each term of a polynomial will have a coefficient. Okay. So for example, coefficient of x squared is equal to positive 1. Coefficient of x is equal to positive 2 in this example. Now if I were to consider, say this example, coefficient of x squared is minus 1, coefficient of x is 4, and the constant term of course is 7. Now, there could be an example which looks like, say, we have 2 or minus 7 or 7. Now, these are referred to as constant polynomials. Constant polynomials. Because there is no x term. The constant polynomial 0, okay, if we consider 0, this is referred to as a zero polynomial. Okay, now let us look at a few expressions which look like this, which is x plus 1 by x, or say root x plus 3, or you have cube root of y plus y squared. So in the first example here, I have a negative power of x because x power minus 1 is 1 by x. This is not a polynomial. I have root x, that is irrational. Okay, and here we had negative power of x. So therefore, this is not a polynomial. And cube root of y is equal to y power 1 by 3. This is also not a polynomial. So different cases where the given expression will not be a polynomial when you have a negative power, when you have an irrational number or entity, or if you have y raised to a rational number, which is an example here, y power 1 by 3. Because 1 by 3 is not a whole number. Next, if the variable in a polynomial is x, okay, if the variable in a polynomial is x, then we denote that polynomial as p of x, okay. So, for example, say p of x is equal to 2x squared plus 5x minus 3. Or let me take another example. Maybe r of y is y cubed plus y plus 1. So the variable here is y. So I refer to this polynomial as r of y. Let me take another example. S of u, which is 2 minus u squared plus 6u power 5. So the variable here is u. So we'll look at polynomials having only two terms. Polynomials with two terms. They are referred to as binomial. Okay. So if it is one term, then we call that as monomial. If we have two terms, then that is binomial. And if we have three terms, you can refer to that as trinomial. And say we have more terms, then you refer to that as a polynomial. So let's consider the examples here for binomial. So p of x is equal to x plus 1. Q of x is equal to x squared minus x. R of y is equal to y power 30 plus 1. T of u is the variable here, u power 43 minus u squared. So these are examples for binomials. Now let's look at examples for trinomials, meaning there are three terms. So p of x is equal to x plus x squared plus pi. Pi is a constant and the variable here is x. Q of x is equal to root 2 plus x minus x squared. The variable is x here. R of u is equal to u plus u squared minus 2. Say t of y and y power 4 plus y plus 5. Okay. Next, let's understand what degree of a polynomial is. Okay. So degree of the polynomial is the highest power to which the variable is raised to. The variable is raised to. Okay. Let us take this example. Say p of x is equal to 3x power 7 minus 4x power 6 plus x plus 9. So here the variable is x and the highest power of x is 7. Therefore, the degree is 7 for this given polynomial. Let's take another example here. Say q of y is equal to y power 6 minus 4y squared minus 6. So here the variable is y and the highest power of y is 6. Therefore, the degree is equal to 6. Now, let's consider this example where it is a constant polynomial. Constant polynomial. So I will add another attribute here. I'm going to say it is a non-zero constant polynomial. In that case, the degree is simply equal to 0. Okay. For example, say it is 7. Now 7, I can write it as 7 into x bar 0, because we know x bar 0 is 1 provided x is not equal to 0. So in this case, the degree is equal to 0. So let's examine these polynomials. Question is to find the degree of the polynomial. Find the degree. Okay, first question, x bar 5 plus x bar 4 plus 3. So here the variable is x, highest power of x is 5, therefore the degree is equal to 5. Next question, 2 minus y squared minus y cubed plus 2y power 8. Here you will notice the variable is y, highest power of y is 8. Therefore, the degree is equal to 8. Next example, 2. So this is a constant polynomial and therefore the degree of the polynomial is equal to 0. So this is a non-zero constant polynomial. Okay. Now, based on the degree of the polynomial, we can classify into different types of polynomials. So let's consider this table, degree and the type of polynomial. If the degree is 0, then it is called a constant polynomial. If the degree is 1, it is called linear polynomial. If the degree is 2, then it is called quadratic. And if the degree is 3, it is called cubic. Okay. So let us see the standard form for linear. It is ax plus b provided a is not equal to 0. Next is quadratic. Standard form is ax squared plus bx plus c provided a is not equal to 0. So in this case, a is the coefficient of x squared. In the previous linear expression, linear polynomial, a was the coefficient of x. Let's look at the standard form for cubic polynomial. Ax cubed plus bx squared plus cx plus d provided a is not equal to 0. That is, in this case, a is the coefficient of x cubed and a, b, c and d. A, b, c and d are real numbers. They are real numbers. Now, degree of a zero polynomial is not defined. Degree of a zero polynomial is not defined. So with this background, now let us understand the general expression for a polynomial in variable x. So say the variable is x and the degree is n. Okay. Then the general expression for the polynomial is given by a n x power n plus a n minus 1 x power n minus 1 plus so on plus a1x plus a naught. Okay. So here a naught, a1, a2 so on up to an are constants or they are real numbers. Okay. And what is the condition here? An is not equal to 0. An is referred to as the leading coefficient. Next, we will look at zeros of a polynomial. So consider the polynomial p of x is equal to 5x cubed minus 2x squared plus 3x minus 2. Okay. So let me put a value of x is equal to 1. Then I get p of 1. So in the above polynomial, wherever x is there, just put x is equal to 1. So 5 into 1 cubed minus 2 into 1 squared plus 3 into 1 minus 2. So that gives me 5 minus 2 plus 3 minus 2. 5 plus 3 is 8. Minus 2 is minus 4. 8 minus 4 is equal to 4. Therefore, we say P of 1 is equal to 4. So how do we read this? Value of P of x at x is equal to 1 is 4. Okay. So similarly, we can find P of 0. P of 0 will be equal to minus 2. So now, next question. Say P of x is equal to 5x squared minus 3x plus 7. Okay. And let us find the value of P of x at x is equal to 1. So that's the question. P of 1 is equal to 5 times 1 squared minus 3 times 1 plus 7. That gives me 5 minus 3 plus 7, which is 12 minus 3, which is equal to 9. Therefore, P of 1 is equal to 9. So let me consider a linear polynomial. Say P of x is equal to x minus 1. So if I put x is equal to 1, I get P of 1, which is 1 minus 1, which is equal to 0. So P of 1 is equal to 0. Then we say that 1 is a 0 of the polynomial. Similarly, let's consider, say, q of x is equal to x minus 2. So if I put x is equal to 2, I get q of x is equal to 2 minus 2, which is equal to 0. So q of 2 is equal to 0, which implies 2 is a 0 of the polynomial q of x, of the polynomial. Now, suppose I write only p of x, then this is a polynomial, okay? And if you get a value of 0, you call that 0 of the polynomial. But if I put p of x is equal to 0, then it is called a polynomial equation. Polynomial equation. And then you refer to the value of x which makes p of x equal to 0 as root of the polynomial equation. Root of the polynomial equation. So understand the difference between 0 of the polynomial and root of the polynomial equation. So suppose I take the example x minus 1 is equal to 0, then this is a polynomial equation. In this case, it's a linear equation because the degree is 1. So x is equal to 1 is the root of the linear equation. So note here, a non-zero constant polynomial, a non-zero constant polynomial has no zero. So you can generalize that every real number is a zero of the zero polynomial. Okay, with that, let's look at this question. Check whether minus 2 and 2 are zeros of the polynomial x plus 2. Okay, so let us begin with taking, let p of x be equal to x plus 2. Let us put in p of 2. So that gives me 2 plus 2, which is equal to 4. Okay, therefore, what do you conclude? 2 is not a 0. Next, let us put x is equal to minus 2. So, minus 2 plus 2, which I get it as 0, which implies minus 2 is a 0 of the polynomial. Next question. Find a 0 of the polynomial. Question is, find a 0 of the polynomial. So the given polynomial is p of x is equal to 2x plus 1. So how do you find a 0? By simply putting p of x is equal to 0. Therefore, 2x plus 1 is 0. 2x is equal to minus 1. X is equal to minus half. Is a 0 of the given polynomial. So now that I've taken a linear polynomial here, let me consider the standard form of linear, which is ax plus b, and let me equate it to 0. So ax is equal to minus b, x is equal to minus b by a. This is called 0 of the linear polynomial. Okay, this. Next one, verify if 2 and 0, verify if 2 and 0 are zeros of the polynomial x squared minus 2x. So again, let me begin with putting p of x is equal to x squared minus 2x. Let me put x is equal to 2. So I get p of 2. So in the polynomial, in place of x, I'm going to put 2. 2 squared minus 2 times 2. That gives me 4 minus 4, which is equal to 0. So therefore, you can say 2 is a 0 of the polynomial. Next, I'll put x is equal to 0, which is 0 squared minus 2 times 0, which is 0 minus 0, which is 0. Therefore, 0 is a 0. Okay, so now let us list our observations so far. A 0 of a polynomial need not be 0. Need not be 0. 0 may be 0 may be a 0 of a polynomial. Every linear polynomial has one and only one zero, has one and only one zero. A polynomial can have more than one zero. So next we will look at the remainder theorem. And for that, let us use this as an example where we are doing polynomial division, or also known as long division. Okay, so the question is 3x squared plus x minus 1 divided by x plus 1. So x plus 1 is my divisor and my dividend is 3x squared plus x minus 1. So 3x squared here, so I'll multiply x by 3x to get 3x squared plus 3x. Now I'll subtract, change the sign, 3x squared minus 3x squared gets cancelled, plus x minus 3x is minus 2x, bring down minus 1. So minus 2x here, so I multiply by minus 2. Minus 2x minus 2. Now change the sign to subtract. 2x minus 2x gets cancelled. 2 minus 1 is 1. So this is my quotient and this is remainder. Okay, so now this is called the division algorithm, which is dividend is equal to divisor into quotient plus remainder. So let us generalize this. Say P of x is the dividend and G of x is the divisor. Quotient is Q of x and remainder is denoted by R of x. So now in this example, I had the divisor as x plus 1. So if I put this as equal to 0, I get x is equal to minus 1. What was my dividend? 3x squared plus x minus 1. So this is p of x. Now, if I were to find p of minus 1, p of minus 1, okay, I get 3 times minus 1 whole square plus minus 1 minus 1. 3 minus 1 minus 1, 3 minus 2, which is equal to 1. So p of minus 1 is equal to 1. So you will notice here that the remainder obtained on dividing p of x by x plus 1 is the same as the remainder that we obtain. Okay, is the same as the value of the polynomial p of x at the 0 of the polynomial. Same as value of the polynomial p of x at the 0 of the polynomial. So based on this, now let us understand the remainder theorem. Let p of x be any polynomial. Let p of x be any polynomial of degree greater than or equal to 1, and let a be any real number. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. Okay, so let's see the application of this remainder theorem. Question is find the remainder. Find the remainder when x bar 4 plus x cubed minus 2x squared plus x plus 1 is divided by x minus 1. Okay, so what is the 0 of the divisor? 0 of x minus 1. I put x minus 1 is equal to 0. So I put x is equal to 1. So let me put p of x, which is x power 4 plus x cubed minus 2x squared plus x plus 1. I will put x is equal to 1. So I find p of 1, which is 1 power 4 plus 1 cubed minus 2 into 1 squared plus 1 plus 1. Let me simplify this. 1 plus 1 minus 2 plus 1 plus 1. That is 4 minus 2. P of 1 is equal to 2. Therefore, by the remainder theorem, the remainder is equal to 2 when the given dividend here is divided by this linear polynomial, which is x minus 1. So in the next session, we will look at factorization of polynomials. Then we'll also look at factor theorem and algebraic identities. So with that, thank you, and signing off with Mana Labs. All the best.